Welcome to part 2 of this video. We're going to continue solving ODEs with conditions, also known as initial value problems. And so let's get started. So this one, as usual, we're just going to do the characteristic equation. So r squared minus 6r plus 25. I can't think of a way to factor out 25 to get 6. So we're just going to use the quadratic equation. So this would be r is equal to 6 plus or minus the square root of 36 minus 4 times 25 all over 2. This will give us 3 plus or minus 100. So 36 minus 100 is square root of negative 64. Square root of negative 64 is 64. 8 I divided by 2 is 4. So again, another case of complex conjugates. That's A, that's B. So our y of t, general solution, would be c1 e to the 3t cosine of 4t plus c2 e to the 3t times sine of 4t. So now to plug in our conditions, so y of 0 will give you c1, which should give you 3. And then y prime of 0, 3 c1 plus 4 c2, and that is equal to 1. We know what c1 is, so this will just pretty much be 9 plus 4c2 is equal to 1. So c2 is negative 8 divided by 4, negative 2. And this makes our solution being 3e to the 3t times cosine of 4t minus 2e to the 3t sine of 4t. And so then let's move on to our last example. So our last example was a little bit different. It involves a third derivative, and it's just pretty much showing that you can use the characteristic equation no matter how high the order is, as long as it is homogeneous and has constant coefficients. So this one, the characteristic equation will just be not r, will be 3r cubed plus 2r squared, and that is equal to 0. We can factor out the r squared, so this will leave us with 3r plus 2 equaling 0. So our solutions, because it's a cubic, there'll be 3, there'll be 0, 0, and then negative 2/3. This makes our general solution being c1 plus xc2 plus c3e to the negative 2/3 t. And so now to plug in our condition. Actually, before I do that, I'm going to actually take the derivative. So y prime will be equal to c2 plus, not plus, minus 2 over 3 c3 e to the negative 2/3 t. Then y double prime will be equaling 4/9 e to the negative 2/3 t. So when we plug in y is equal to 0, we will get 0, 0. So this would be c1 plus c3 equaling negative 1. When we have y prime is equal to 0, we will get c2 minus 2/3 c3. That would be 0. And then for the second derivative, that's equal to 0, we will get that. I forgot to multiply it by c3. 4 over 9 c3 is equal to 1. So this one's really easy to solve since this will have one variable. So c3 is equal to 9/4. And since c3 is equal to 9/4, we can go ahead and plug it into the first equation. And so this becomes c1 equaling to negative 1 minus 9/4, or negative 13 over 4. And then the second equation will be, what is the c1? Okay, C2 will be positive, so 2 over 3 times 9/4, or 18 over 12, which is 6/4. And so our solution to this, or a particular solution to this equation, will be y of t is equal to C1, wherever you are, negative 13 over 4, plus x times 6 over 4, plus 9 over 4 e to the negative 2/3 t. And that is pretty much it for this video. Next up, we will be discussing about non-homogeneous systems. Since we discussed about homogeneous, it's fair to say that we should discuss about non-homogeneous systems and then how to solve them. And so in the meantime, have a great day, and I'll see you in the next video.